Diophantine equations. Example 11.2. A farmer spent $100 to buy 100 animals of three different kinds. Cows cost $3 each, pigs $2 each, and sheep 25 cents each. Assuming he purchased at least one of each animal, how many of each did he buy? So again, I'm going to let x equal the number of cows, y equal the number of sheep, and z equal the number of pigs. All right, I need to create two equations. The first one's going to be x plus y plus z equal to 100, because I know we had 100 animals. So I know that x plus y plus z has to add up to 100. The second equation will be about how much they cost. So since cows are $3 each, that's 3x. Sheep are $2 each, that's 2y, and pigs are 25 cents each. Well, 25 cents is a quarter, so that's a quarter, or 1/4 z is equal to $100. And just as in the previous example, I did not like that fraction, so I want to clear that fraction, which means I'm going to multiply everything in that second equation through by 4. And that's going to give me 4 times 3x, that's 12x, plus 4 times 2y, that's 8y, plus z equal to 400. And then again, I'll subtract out the first equation to eliminate the z's. Okay, and I just see that I made a little mistake up there. That should be a z, excuse me, plus z. Okay, all right, so when we do the subtraction, I have 12 minus 12 minus 1, that's 11x, plus 7y equal to 300. And again, what you want is you want to eliminate one of the variables. So these z's, since they both had a coefficient of 1, subtract out very nicely. All right. Now we're going to solve for one of these variables. And as I said in the previous example, to lessen the amount of work you have to do, solve for the variable that has the lower coefficient. So we're going to again solve for y because 7 is smaller than 11. So I'll subtract 11 from both sides of the equation. (11x), and then divide both sides by 7. So I have y equal to 300 minus 11x all over 7. And I'm now ready to begin my feasibility table. And we're going to be picking out x's, all right, because that's the first thing you do is you're going to pick an x and then you plug it into this equation and that gives you a y. And if that y is a feasible solution, then you're going to solve for z. And what you'll do to solve for z is you'll use the fact that x plus y plus z has to equal 100. So z is going to equal 100 minus y minus x. All right, those three numbers have to add up to 100. So if we should find a feasible y, then we'll go and get the value for z that goes with that x and that y. Okay, so as I said before, to determine where you're going to begin in x's, you need to find the largest value of x that you can that will still produce a positive y. So you don't want to subtract out too much because if you pick a number for x such that when you multiply it by 11, it gives you something bigger than 300, you're going to get a negative numerator and then that new number is going to be negative. So you don't want that. So in order to do that, you simply divide 300 by 11, and that gives me 27 point whatever, all right? You drop off all the decimals, and we use that whole number, all right? So always round down. Even if it had been 27.9, you round down, all right? Because that would be the largest value that you start with, all right? So we're going to start with that 27. And then we're going to have to check 26, 25, 24, and so forth until we look at all those feasible x's. So when I start with 11, when I start with 27, I do 300 minus 11 times 27, all divided by 7. Now, when you're working with your calculators, either put the numerator in parentheses and then divide the entire expression that's inside the parentheses by 7, or hit the equal or enter button after you figure out what the numerator is and then just divide that answer by 7, because you don't want to have a mistake in your calculation by not putting parentheses around that entire numerator. Otherwise, the only thing that's getting divided by 7 would be the 11x. And you don't want that. You want the entire numerator to be divided by 7. So plugging in 27, I have 300 minus 11 times 27, all divided by 7 is 3/7. So that's no good. All right, when I plug in a 26, I have 300 minus 11 times 26. And then I hit my equal button, and then I do divided by 7, and I get a 2. Okay, this is good. We've got a feasible solution. All right, so to get y, I simply do, I have y. To get z, I simply do 100 minus 2 minus 26, and that gives me 72. So my first solution is x equal to 26, y equal to 2, and z equal to 72. All right, now I'm going to give you a little bit of help here, because I know you may be thinking, what a pain in the neck. I'm going to have to check 25 more values for x. But once you found a hit, you can use your denominator to help you get to the next hit. What you're going to want to do is you're going to want to subtract out 7 from this 26, from the one that you just found over here. So 26 minus 7, you're going to go down 7 more, and that's going to give you your next hit. So let's make a new table up here. All right, and let's just put in our first hit of 26 to 72. And we know that our next hit is going to be 26 minus 7, or 19. All right, so you want there to be a difference here of 7. Okay, all right, so when we plug in the 19, 300 minus 11 times 19, hit enter, then divide that answer by 7, that gives you a 13. And then to get the z, you want to do 100 minus 13 minus 19, and that gives you 68. So there's my next solution. And then to get to my next one, I'm going to subtract out 7 again, and that's going to give me 12. So when I plug in 12, you're going to have 300 minus 11 times 12. Hit enter, divide the answer by 7, and you get 24. And to get the value for z, you do 100 minus 24 minus 12, and that gives you 64. So there's my next solution. Okay, I can subtract out 7 again, and that's going to give me 5. Plugging in 5 into my y equal equation, 300 minus 11 times 5, all divided by 7 is 35, and then 100 minus 35 minus 5 is 60. Now, I know I have no more solutions, because if I subtract out 7 again, I'm now down to a negative 2, and I can't have negative values for any of my variables. All right, so here are the 4 solutions to my Diophantine equation. And when you're doing your homework, the answers are given as ordered triples. So in other words, this would look like 26 to 72. And this one would look like 19, 13, 68. All right, and again, it's just like an ordered pair, except instead of values for x and y, now you've got values for x, y, and z.